Master the ultimate AI ML skill set with the world's number.
Yeah, yeah. Microphone. I changed it. Now is it audible? Is it audible now? And now it is showing. Now audible. Thank you. Okay, I am extremely sorry because I'm not familiar with all these things. Uh, so I'll start very quickly. Thank you so much. Thank you for your patience. I am very sorry. Okay, so today we are going to discuss about the current sensing and ABC to DQ transformation. Okay, so first we'll very quickly we will learn. We will not go that much details, but we will learn the extent we need. So current sensing, because uh, in motor control the estimation of the rotor flux is very important. You know, rotor is rotating, so there is no we cannot directly sense it. We have to estimate it by sensing the current and RPM or this kind of things we have to adapt. So current sensing is a very crucial and important task for a control engineer to control the motor. Okay, so normally we use this sensor. It is called LEM sensor. It's a like Hall effect sensor. So it's look like this. So this is the model number LA100T. So it can sense up to the primary current. It can take up to 100 ampere RMS. And you see there are two pins. Okay, there are three here, two pin and this one. So you see this is M, written M. This is the measurement pin, and this is the negative sign, and this is the positive sign. Okay. Now I am coming to the connection. So in that previous, see here one arrow is given like this. So your current carrying wire should come like this. Current should flow like this. So you have to follow that direction. This is the arrow, and as I told, one positive terminal is there, one negative is there, and one measurement is there. So here you connect the DC power supply 12 volt, and this is the microcontroller or PLC, whatever may be. Use one measuring resistance here, and another end you ground with the microcontroller, and from here you connect to the ADC. This is the connection. Okay, now how to select that measuring resistance? This is the data sheet of that. See, this is LA55. So this is the data sheet, and you see the maximum based on the impedance of the sensor, output impedance of the sensor, the resistance maximum you can connect like this. So this is the data sheet. Based on that you can select it, you can go through in details, and while you will be working you will be understanding it. Okay, this is the, I have given the glimpse of that. So this is the current sensing. Now I am coming to the main thing, which is ABC to DQ transformation. What is that? Now let us understand one thing. If this is the horizontal axis and this is the vertical axis, and if this is a vector and if this is theta, then this component is called the cos component, and this component is called the sine component. Okay, now we will be first learning ABC to alpha beta, means it is 3-phase to 2-phase transformation. Say, let take this is my A phase, and B phase we know it will be aparted by 120 degree, and C phase it will be aparted by again 120 degree. Now I am, say this current is IA, this current is IB, and this current is IC. So how to sense the current? Through LEM sensor. Just now we learned it. Now I am making one more axis, which I am giving alpha axis, which is just in line with the A axis, and another axis beta, which is just perpendicular to the alpha axis. Now as we learned, the horizontal component will be always the cos component of the angle. So I alpha is equal to IA, the angle between A and alpha axis is 0, so this will be cos 0, plus IB, the angle between alpha and B axis is 120, so cos 120, plus IC, and the angle between alpha and C axis is 240. Okay, very simple. Now what is I beta? Those I beta is the vertical axis here. So as I told, it will be sine component. So that is IA sine 0 plus IB sine 120 and plus IC sine 240. Okay, now if you write all these things, and we always consider it's a balanced load, and this summation of these three currents IA, IB and IC is 0, and now if we write in a matrix form I alpha, I beta and 0, this is equal to cos 0, cos 120, cos 240, sin 0, sin 120, sin 240, and this is 1 1 1. This is IA, IB, and IC. It's a matrix form. So this transformation is called ABC to alpha beta, or stationary axis to axis transformation, or 3 to 2 axis transformation. Okay. So why it is required, all these things will be that time we will recall when the that particular lecture will come. I will remember you that it already we have learned there in lecture 4, like that I will be telling you. Okay, so I think it is very simple mathematics, nothing to worry. So this is the things called 3-phase to 2-phase transformation. Now we, from by sensing the 3-phase current, we convert it to alpha and beta. You can assume this is the stator. Now stator reference frame, from 3-phase we have converted to 2-phase. Now we will define one more axis, which is direct axis, and another q axis, which is quadrature axis, and this is 90 degree, and this angle is theta. Means in asynchronous machine normally this theta is never equal to 0. As I told, there will be some angle. The rotor flux will never able to catch the stator flux. Now we have to find out the relation because alpha and beta we already estimated. We measured through our LEM sensor, and using this trigonometric conversion we converted that ABC to alpha beta. And now if we able to know the position of the rotor flux, then we can estimate the current flowing through the rotor, which is D and Q, and we can inverse transform it, and we can find out the ABC, the 3-axis current for which is flowing through the rotor. This is the indirect method to measure the rotor current, because directly you cannot put any sensor there, correct? But this will be required to control the motor. So again I am writing. So this I alpha is equal to the angle between alpha and D is theta. So ID cos theta and the angle between Q and alpha is 90 plus theta. So cos 90 plus theta. I beta, it is ID cos theta plus sin theta plus IQ sin 90 plus theta. Now if you write in matrix form, is I alpha I beta, which is equal to cos theta, and cos 90 plus theta means minus sin theta, this is sin theta, and sin 90 plus theta is cos theta. and this side is your ID and IQ. Now if I need to find out ID and IQ in terms of alpha and beta, then I have to take the inverse of this. So this is plus, minus, minus, plus. So we have to take the cofactor column wise or row wise, and you have to put column and row wise. If I take column wise, I have to put row wise. So if I take this first term, so this will be cos theta, because this and this will be cancelled, so it will be cos theta. Okay, and then one minus sign it will come because it is minus sin theta. Then I will take, this is minus. Okay, so this is minus, so this it will be cancelled, so minus of minus sin theta means sin theta, and this, so it will be cos theta. So this is my ID and this is my IQ and this is my alpha and beta. So this transformation is called alpha beta to DQ transformation. That means from the stationary axis to rotating axis transformation. So it is very clear, it is nothing, it is simple trigonometry, nothing else, need not to worry. So we understood how to sense the current. You take the current to your PLC or microcontroller, that is the phase current. Then you first convert that things to alpha beta. Once you know the alpha beta, you capture the theta somehow you estimate, and use this matrix, multiply with this, and you get DQ, ID and DQ. That is nothing but the rotor side current. This is very simple. Now the question, now I will give you a very short glimpse how to read the ADC. So first people mostly they will prefer, because they know Arduino ID. So I will use Arduino ID, but we should not use the library function for any IDE. Better to write register level when you are going for customized application. First, I am not going to DSP. Frankly speaking, this vector control, all kind of motor control already I have implemented in 8-bit controller, any 8-bit controller, in Texas controller, in Atmel controller, in PIC controller. 8-bit controller itself sufficient to do all this kind of control if you know the things properly. Don't use any library function. You read the datasheet. To learn a microcontroller, datasheet is the best book for it. It's from my experience I am telling. So as I told, I am using Arduino IDE. So few functions I will be used from AVR library. So that's why I have included this header file. And this interrupt we will learn the next lecture or some subsequent lecture. What is this interrupt? And this is the place for global variable declaration, and this is the main function. And here this is the initialization. It is called initialization. This function will execute for once to set up the microcontroller. Okay, so here I have used one user defined function called ADC_init. That I have written here. This is the ADC_init. We will understand what are the bit I have used. So you see here I have used ADC SRA. This is the datasheet for that. So ADC-SRA, let us find out what is that bits. My PC is very slow, so you have to bear with that. This is the ADC-SRA register. Okay, so in ADC-SRA register I have used ADPS bit. So this is 1 and not means 0. 1 0 0. Why I have used that? So these things I will discuss later, because the next course is coming on basics of microcontroller, 8-bit and DSP, all these things. It will be, so you can join, you can learn it in details. Today I am not going to details. You see, this is called the prescaler bit. These bits determine the division factor between the system clock frequency and the input clock to the ADC. Because why? Because this is a flash type ADC. It has its own conversion time. If you read the datasheet, you will understand. So before completing the conversion, if the another cycle start, ADC will not able to perform its intended operation. So that's why I divided. What I used 100. So I divided the clock. I am slowing down the clock by the factor of 16. Why it is, those are the everything given there. You will, because this is single-ended conversion, so you will understand everything if you read it. Already in your graduation, in your digital electronics, you have read the ADC. So this is not a big thing, you will understand, but I am just telling why I have given so. So now we have understand why I have said this. Another is ADEN bit. This is the ADEN bit. What is that? You see, another bit is here, ADEN. What is this? Writing this bit to 1 enables the ADC, because I am working with a ADC, so definitely I have to enable it. So I have done this. Now another function I have used, that is read ADC, and you see in the while one loop, this is the always true loop, I am reading using this. Okay, so what is that read ADC? In read ADC I have setting that AD marks. So let us see what is this AD marks. This is AD marks. किधर गया AD marks? Okay. कहाँ गया भाई? Yeah, this is ADC multiplexer selection. So I have used these 2 bits, the last 2 MSB and the last 4 LSB I have used. Okay, you see I have used 0 1. So what is that 7th and 6th bit? That is the voltage reference selection. 0 1 means it is with external capacitor at analog reference pin. So already it is in that particular board, already the analog reference pin is connected with through a capacitor internally with 5 volt, and this is a 10-bit ADC. So if 0 volt is coming, it will be giving a count of 0. If it is 5 volt is coming, it will give a count of 1023. If you use, and here instead of that, if you connect 12 volt, it will read 12 volt. So maximum how much voltage can be read, that you can see in the data sheet. You can use internal reference of 1.1 volt. Some people are needed, so you are using that. And what is, and I have used this 4 bits, that marks bit. What is that? You see, this is the channel selection. 0 0 means ADC is 0, and this is like this. It will be these details are given here. And now see, for channel 1, the argument is, the function argument is the channel. If channel is 0, this is 0th channel. If the channel is 1, it is 1. If the channel is 2, it is 0 0 1 0. Like that I have written for the 5. Now I have used one bit ADSC. Let us see what is that. That is in ADS array. That is in ADCS array. I am telling you this. If you understand these things, you can use any microcontroller. I am telling you. You can use any microcontroller. 1 minute just. Okay. So if you understand this, because it's a, as I told you, it's a 8-bit register, so that's why here 8 bits are there. In 16-bit, here one more column will be there. For 32-bit, 2 more column will be there. Like that it is there. But the thing, if you understand, if you read it by your own, you can do. Please believe me, coding is not at all an issue. People are afraid of this coding, but you can use any kind of IDE. You can use Arduino, you can use Energia, you can use the MPLab, you can use the Code Composer Studio, you can use Scale, you can use some other thing. Recently I have worked for some company, they are used something. It is nothing. ST Microelectronics, some compiler is there, IDE is there, anything you can use. It is nothing. So what I was telling, ADSC. So this ADSC means this is the 6th bit start conversion. You see, if in single-ended conversion mode, write this bit to 1, start the each conversion, and you see it will take around 25 ADC clock cycle. Okay, so that's why I am writing this bit to 1 to start the conversion, and once until the conversion is there, it is converting, this will be high. You see, ADC will read as long as conversion is in progress. Once complete, it's returned to 0. So as I was telling, till the conversion is completed, I should not give another task. So I am taking that program counter inside this and telling chup chap baitho, don't do anything. Once the conversion completed, then this condition false and it will return the ADC word. You see, sorry, the ADC word register. So ADCH. You see, this is the so these two, ADCH and ADC low, high and low bit, as I told, it is 10 bit. So you see, from ADC8 all total 8 bits are used, and ADCL these 2 bits are used. So that's why that ADC is 10 bit. Okay, so now my things are completed and I am reading this in and storing it XYZ and ABC, and I am printing it. Okay, so this is the thing. I have taken that, I have already compiled the binary and generated the hex code. Now I am running it. You see, it is reading. Only 2 channel I have connected, and you see it is changing. Okay, so the speed, at what speed you will be you want the conversion, all these things that you can fine tune based on your requirement. Okay, so what I mean to say, why I told this, because finally we will be going at the end of the course, all these things will be required. How to read how to capture, because we have to capture the current. In case of microcontroller or PLC, same settings, only the name will be changed. As I was telling, if you know the composition of the medicine, it is immaterial to manufacturer of the medicine. Okay, I have some muscle pain, so people used to tell some brand. No, you need not to tell that always, because say I am here in Tamil Nadu, they are using one brand, but if I go to Delhi, it may not they may not be knowing that, because that may not be popular there. So the composition of that muscle spray is methyl salicylate. You tell I want methyl salicylate spray, methyl salicylate, and there will be cooling menthol, methyl salicylate and menthol spray they will give. Like that way, any one microcontroller, if you learn in this register wise, you see, I will be this for DSP. For DSP, I used to teach this controller only. But the same thing, the thing is, you may not able to get the desired output sometime if you don't write the code based on your requirement. Always it is advisable to write the code register wise. Okay, so this was all about today's lecture. Now you can ask few questions. Which datasheet you are using, sir? I'll show you. The datasheet is, this is the datasheet. It is Atmega 328P 8-bit AVR microcontroller. Recently it is taken over by Microchip. It is Atmega 328P. Atmega 328P, manufacturer is Atmel. Recently it is taken over by Microchip. Any question? Now you can ask. Why do we do the conversion? Without that conversion, how you will calculate? Because I told you need to convert for the motor control. There is a need to convert to capture the current. You need to capture the current. It's a analog current, analog value. So now you have to convert into digitally, because microprocessor do everything digitally. So you need to convert it. correct? So why this conversion is required, that I will tell you, because it is a sequential process. If I tell things together, it will be boring for you or it will be bulky. That's why I am just telling one by one. This is the way to capture the stator current and convert into two-phase current, and from two-phase stator current to estimate the rotor current if the theta is known. Alpha and beta is always, yeah, alpha and beta and D and Q, they are in quadrature, means in perpendicular 90 degree. How frequently we capture the current? Yeah, it's a very good question. So you see, that is depend on the switching frequency. Say my switching frequency is 1 kilohertz. That means every 1 millisecond my controller should give the switching pulse to the duty cycle to the IGBT. So my entire conversion, not only this, capturing the current, doing all the calculation, everything should complete before that 1 millisecond. If it is calculating after 2 milliseconds, then no use, na? No use. So these are the things, fine engineering is to be done and all the calculations are to be done based on your entire specification. Same time. And I will show you one for I wrote one electric kettle, electric vehicle. One book I am just showing you. See, this is the book. It is, I wrote this maybe 3 or 4 chapter of this book. This is basically for artificial intelligent technique for electric and hybrid vehicle control. So in this book, this is the book. Here the AI and the chapter 6, 7 and 14, especially it is for motor control and reliability analysis of batteries, semiconductor device and all. And chapter 14 is especially for motor control. So you can refer this book. This book, those chapters are wrote by me only. That is a costly book, but so how we can do it practically? Yeah, I will show you that all these things at the end of this course, your all queries, it will be resolved. You will be showing the entire thing in front of your eyes, how it is done. Because here I cannot show you, because everything is it is in my lab, so I cannot show from there. I'll took some video and I will show you that whatever we learned, we implemented it and it is working. So any further question, or I can terminate the session? So hope you have understood the ABC to DQ transformation and the ADC settings, whatever I have shown to you. This is because this you should remember. This will be needed for the subsequent, because when I will be simply doing that ABC to DQ transformation, that time you should not ask, sir, what is that? That means it is again problem, because already you have learned. If I sense the three-phase current, if I know the theta, then I can convert that current to DQ. Simple. So this inner of that ABC to DQ transformation we have learned. ABC to alpha beta to DQ. That's all. So thank you so much. We will see tomorrow morning. Till that,